In this video, we'll review 5 questions that cover Target 2C. We're going to start with question number 11, move on to 12, 13, 14, and we finish up with question number 15. So question number 11 is asking us to factor this trinomial. So a shortcut to do this is we need to, well, I'm going to start by writing an x, right? And we need to come up with two numbers that multiply together to give me a negative 12. So I'm going to put this constant always up here in this top part. And then we need two numbers, that same two numbers to also add together to be a positive 4. So they need to add together to give me positive 4. So what are these two numbers going to be? I'm going to start off by setting up some factors here. So what times what will give me 12? I always start with 1 times 12. Now because we have a negative number up here, we need one of these numbers to be negative. And because we need to have those two numbers add together to be a positive number here, we're going to make that positive number be positive. We're going to make the higher number be positive, and then that lower number is going to be negative. So what else times, what times what gives me 12? So that's going to be a negative 2 times 6, and then a negative 3 times 4. All these are factors of 12. And again, we want to make the smaller number negative so that when these two numbers add together, we get our positive number. So the two numbers that add together to give me a plus 4 is going to be negative 2 and 6. So I write my factors by writing x minus 2. That's one factor written as a binomial. And then our other factor is going to be x, and we had a positive 6. That all will be set equal to 0. And now we have to solve this, so we set both of these binomials equal to 0. And then we solve each one. So to the left, I add 2 to both sides. This cancels out. I'm left with x equaling positive 2. And on this side, I want to take away 6 from both sides. So that cancels out. And I'm left with my other x value equaling negative 6. So there, we factored it, and we even did some extra stuff. We solved it as well, and I don't even think we were supposed to do that. Question number 12 now wants the factors, and we also want to solve. So we want to do both of those. Just like my last problem, we have to start with an x, and then this constant goes up here in the top part. So we need two numbers that multiply together to get a negative 122, and then we need those two numbers to add together to give me a, well, in this case we don't have any middle term, and that's because it's 0. If you look at this trinomial right here, imagine if we had a 0 for this middle term. You wouldn't want to write that because 0 times x is just 0. So you'd write x squared minus 121 equals 0, just like what we have here. So now that we need both of our numbers to add together to be 0, we know that those two numbers are going to be identical, and one of them is going to be positive and one of them is going to be negative. So what number times itself gives us 122? I'm sorry, that should be actually a 1, right? Sorry about that. So we know that 11 times 11 gives us 121. So our two binomials are going to be x minus 11 times x plus 11. Because 11 times negative 11 gives us negative 121. And when we add those two together, we get 0. So technically I can put those here as well if I want to stay organized. We set both of these equal to 0 and solve it. So there's the answer. X will equal 11, and then x will also equal negative 11. Now, something else that you can do whenever you see a binomial here is you can check for the difference of two squares. And this formula right here is what represents the difference of two squares. So what does that mean? Well, whenever we have a leading term right here, that's a perfect square, which x squared is. And whenever we have a second term like this right here, that is a perfect square, which it is. 11 times 11 gives us 121, so that's a perfect square. And they're separated by a subtraction sign. that's going to be the difference of two squares. So what you have to do is figure out what the A term is, so what are we squaring here, and what the B term is, so what are we squaring here. So what are we squaring in front? Just take the square root of that, which gives us x. That will be our A term. Take the square root of the second number, that's going to be B, and that's going to be 11. So then our A is x, and then our B is 11. So there's going to be a plus B, and then you're also going to do an A minus B. Whoops, that should be 11, right? And then those would be two of our factors. It's just the difference of two squares. It's a shortcut for doing this, but this process over here just keeps me consistent with the way we did number 11. Question number 13 is asking us to solve this trinomial, and to solve it we need to factor. Now when we're going to factor to solve and we have a number in front of this x squared term, that should be a red flag, and when we see that, we should see if we can divide out a greatest common factor between each of these three terms. And what that means is, can we divide out a number that evenly goes into all three of these terms? And we can. There's a 3 that divides into them. So I'm going to put a 3 out here in front, and then I'm going to start my parentheses. And what comes next is the answer after we divide out a 3 from each one of these three terms. So here we go. I want to divide them all by 3. 3 over 3 cancels out. We're just left with the 1 there. We're left with then x squared. 27 divided by 3 will be 9, and then I still have an x. And 42 divided by 3 is 14, which all equals 0. Now we can factor this trinomial. So let's just keep this 3 out in front. I'm going to do my x here. My constant, my last number there by itself, goes up here. And then my middle term here goes down in the bottom. So we want two numbers that multiply together to give us 14. And they also have to add together to give us 9. And because we have two positives here, we can keep all my numbers positive. So I start off by coming up with my factors here. So 1 times 14 gives us 14. 2 times 7 gives us 14. And that's going to be it here. So which two pair of these numbers will add together to give me 9? That's going to be 2 and 7. So I put 2 here and 7 there. They're both positive as well. So that's going to help me write my two binomials. So I'm going to do 3 times x plus 2, and then I have my x, we had a positive 7, that equals 0. Now you could just ignore this 3 in front, that's not going to do anything, and if you want to actually divide it out, you can. So if I divide this side by 3 and this side by 3, 3 over 3 is just 1, so that goes away, and then 0 divided by 3 is still 0. So I'm left with x plus 2, and then my other binomial, which is x plus 7, equals 0. I set both of these equal to 0 and solve it, and I'll get my answers. X equals -2 and x equals -7. Number 14 is a word problem, and we need to figure out the outer dimensions. So we gotta solve for x first. Once we have our x value, we can plug that into our formula for width and length, and we'll get those two sides. So I'm going to use the area formula, and that's going to be area equals length times width. So the area of this lot is 140 meters squared. One of the sides, the length, is going to be 2x plus 8. My other side, the width, is going to be 2x plus 12. So using this equation, I could solve it, and I could get my x value, and then I could plug that in for w. So to solve this, I want to first distribute out this binomial times this binomial. So 2x times both of these gives me 4x squared plus 24x. Then I take the 8, multiply it by these two guys, which gives me 16x plus 96. And because I have an x squared and an x here, there's no way I can combine those two to just solve for x. So I'm going to have to factor. And to factor, I need to set it equal to 0. So I want to get everything on one side. So that means I have to take away 140 from this left side, which means I also take it away from this right side. So I'm left with 0 on my left side. And now I just want to combine all these terms. So my only x squared term is 4x squared. I have 24x plus 16x. That's going to give me, what, a 40x? And then 96 minus 140, negative 44. Now I want to factor to solve. So I'm always going to check to see if I have a greatest common factor. And in this case I do. There's a 4 that divides into all three of these terms. So I want to divide out my 4. So that's going to be left out here in front. 4 over 4 goes away, so I'm left with x squared. 40 divided by 4 gives me 10x. Negative 44 divided by 4 is going to be minus 11. I'm going to bring down my 0 equals, and then I'm left with this trinomial. Now, remember, we could ignore this greatest common factor in front. Let's just try to factor this. So I set up my x. Just to organize my work, you don't have to do that either. My constant, which is my number over here by itself, gets put in the top. My linear term, which is in the middle with the x, goes down here in the bottom. And we have to figure out two numbers that multiply together to get negative 11 and also add together to get 10. I start by writing my factors of 11. I know that 1 times 11 gives me, actually that should be a negative 11. So 1 times 11 gives me 11. One of these has to be negative as well. And when we add these two numbers together, we need to get a positive number, right? So that means our smaller number is going to be negative. And those are actually the only two numbers that multiply together to get negative 11. So we're stuck here. If we add these together, fortunately we get a 10. So that checks out. So the two numbers that we're going to use are negative 1 and then 11. So that helps me set up my factors. Once I have that all set up, I can set both of my factors equal to 0 and solve them. So I added 1 over here to get rid of minus 1. I'm left with my x equaling 1. And on this side, I took away 11 to cancel that out, and I was left with a negative 11 being my other x value. Now, which one are we going to use? Are we going to use both? If you look at my equations here for width and length, we need to plug in an x value. But if we plug in that negative, what was our negative? It was a negative 11 and a positive 1 that we were going to use for x's. So x equals negative 11, x equals 1. If we plugged in a negative 11, we would get negative sides over here, which it just can't work. You can't have a negative side, right? So I don't want to use negative 11. I'm just going to use that positive 1. So now for length, my length was 2 times x. Well, now my x we know is 1. I can plug that in, and I can solve for my length. So my length is going to be 2 times 1, which is 2, and then plus 8. So our final answer for length is going to be 10. And what unit was that? I believe that was meters. We do the same thing with the width. We take width. We know that that's 2 times our x, which is now 1, plus 12. So our width is 2 times 1, which is 2, plus 12. And then finally we know that it's going to be 14 meters. So our side is going to be 10 meters by 14 meters. That's going to represent my big ol' rectangle here. Oops, that should be meters, right? So 10 meters by 14 meters. And lastly, question number 15, we want to figure out who's right, Sam or Lena. So if we take a look at Sam's situation here, we had a trinomial, and it looks like he tried dividing out a greatest common factor. And his greatest common factor, it looks like, was 2. So could he have divided out a 2 from this term? Yeah, 2x squared. If we divide out a 2, 2's go away, we're left with just an x squared here, so that's okay. Could you divide out a 2 from this negative 1? Not evenly. It definitely wouldn't have left us with a negative 2x, so that's going to be the mistake right there. She, or he or she, whatever Sam it is, incorrectly factored out a greatest common factor. There was none there. Over here, Lena, she had a trinomial, same one, and she correctly came up with the two factors here. And if you want to check this, you could distribute 2 times x. That gives us 2x squared. And then 2x times a negative 2, that's going to be minus 4x. And then we can distribute this 3 with the x and this 3 with the negative 2. That gives us plus 3x minus 6. Combine all these like terms, we're left with 2x squared minus x, because these two can be combined, and then a minus 6, and that was our starting trinomial right here. And as you can see, she also took these binomials correctly, set them equal to 0, and solved it to get her answers. So that was all 5 questions. To recap, we had number 11 where we solved by factoring. Number 12 was also factoring and solving, but it was the difference of 2 squares. The 13 we solved by factoring, but we also had to take out that greatest common factor in the beginning. 14 was the longer problem where we had to use the area formula to solve for x, and then plug those x values in, or well, we just plugged in the one x value actually. Negative 11 didn't work. We plugged that into our length and width formulas to get our dimensions. And then lastly, we had Sam and Lena. We figured out that Lena did the problem correctly.